In this last lesson on how to pass the unit to NAB at higher, we're going to look at the last question of outcome 4. So it's question 11. The point P, 10, 5 lies in the circle with centre -2, 0, as shown in the diagram here. We have to work out the equation of the tangent to the circle at P. So the technique here is just to find the gradient of the radius, use that to calculate the perpendicular gradient, and then use y take b equals mx take a to get the equation of the straight line. So first of all, we've got the centre point -2, 0. We know this up here. So because we've got -2, 0 here and 10, 5, we can get the gradient of the radius. If you imagine a radius line drawn from here to here, then we want the gradient of that because that meets the tangent at right angles. So the way to do that is delta y over delta x. I always write the 2 points down next to my calculation here. It just really helps me focus on what I'm doing. I'm doing 5 take away 0 in the top and 10 take away -2 in the bottom. Now that works out as 5 over 12, and you'll get 2 marks for doing this, one for understanding how to calculate the gradient and one for doing it properly. Now that we've got the gradient of this line, we can get the gradient of the tangent by using the fact that these gradients multiplied equal -1. So because they equal -1, the easiest way to work out what you multiply this by is to flip it over and change the sign. So that's going to be -12 over 5. So this question's out of 4 marks and we've already got 3. So we've got a point of contact here, which is 10, 5. We've got that point and we've worked out this gradient. So 10, 5, this gradient, use your y take b equals mx take a. Now you don't have to multiply all this out, you just have to substitute in the values. So it's y take away 5 equals -12 over 5, x take away 10, and you will get a mark at that point. If you want to multiply it out, that's fine, but that's where the marks end. And that's the end of the Unit 2 NAB at higher.